Hello, welcome to my channel. In this video, I'll be discussing chemical reaction, which is an important topic in JAMB UTME syllabus. Chemical reaction is a process in which one or more substances are transformed into new substances with different physical and chemical properties. And it forms the basis of a lot of processes in nature, including industries and in our body as human, in which we find digestion and other forms of metabolism, combustion, and synthesis of new substances. Basically, chemical reaction has some components which include the reactants, which interacts to form the product. And usually it is represented with equations like this, in which substance A may react with substance B to form substance C. Okay, there are different forms of this. Two things can react to form one thing, one substance, and one substance can decompose. We'll be looking at the different types of reactions in chemistry, chemical reactions in chemistry. Okay, so and this is a chemical equation that represents a chemical reaction in which carbon reacts with oxygen to form carbon dioxide. And detail of chemical reaction can be given sometimes, in which solid substance is represented with S in bracket, liquid substance is represented with L, and gaseous substance is represented with G, and aqueous solution is represented with AQ. There are several factors that may affect chemical reaction, and these factors include the temperature, pressure, and catalyst, which we'll be discussing when when we go into the topics like energetics in chemical reaction. There are different types of chemical reaction, and I'll be going through some of them. We can't discuss them exhaustively because there are many types of chemical reaction in nature, but the common ones we'll talk about them, which you can see in your exam. The first that we'll be talking about is combination of synthesis reaction, in which two substances combine to form one thing. You see hydrogen combined with oxygen to form water. Okay. Decomposition reaction. One thing decompose or break down to form two or more things, like calcium carbonate decompose to form calcium oxide and carbon dioxide. Displacement reaction is a reaction in which one element replaces the other in a compound. If you look at this, zinc replaces copper in copper 2 sulfates to form zinc 2 sulfates with precipitation of copper. Okay. There is also double displacement. If you look at this is can some other times we call single displacement. In double displacement, there are two compounds that react and each of them exchange ions between them. If you look at this is sodium chloride and silver nitrate. And the silver nitrate exchange sodium for silver, right? And the sodium chloride exchange uh, silver for sodium, and we have these products. Okay, this is double displacement. And combustion is another type of reaction in which a substance reacts with oxygen to produce heat and light. This can be seen when in when you apply oxygen to some gases like methane. It can is what is called combustion. Okay, and you can also see combustion in the working of the automobiles. Okay. Redox reaction is another type of reaction in which electron is transferred from one reactant to the other. Okay. For example, this here, oxygen is receiving electron from magnesium, okay, to form magnesium oxide. Okay. There are different types of oxidation redox reaction. There are different types of redox reaction, which you will be seeing when we get to oxidation reduction reaction. Having talked about the different types of chemical reaction, the next concept that we'll be talking about that is very important in chemistry is balancing chemical reaction. Like I told you earlier, that chemical reaction in chemistry is represented with equations. And one thing that is very important in this equation is that it must be balanced. And this must conform with the principle of the laws of conservation of mass, which states that the total mass of reactants must be equals to the total mass of the products. For example, in the example we look at the other time where hydrogen reacts with oxygen to form water H2O. Okay, if you look at this equation, you can't just leave it like this because on this side there are two hydrogen. On this side there are two hydrogen. Okay, on this side there are two oxygen, but on this side there is only one oxygen. Where is the other atom of oxygen? Where does it go to? So we need to account for that. And accounting for that is conforming to the principle of conservation of mass, which states that the mass of the reactants must be equal to the mass of the products. Okay, so we need to balance this equation. There are different ways we can balance equations. Okay, and one of the ways to just look at it like this. And sometimes you may be used to some chemical reactions in chemistry, and by just merely looking at them, you know where to put what. Okay, and the ways to balance chemical reaction is to apply coefficients to the product or the reactant, whichever case may be, so as to balance the mass on both sides of the equation. This arrow, simply put, represents equals to, like in mathematics. Okay. So now let's balance this equation. If we put 2 here, we now have 4 hydrogen here and 2 hydrogen here. And we have 2 oxygen here and 1 oxygen here. Let's put 2 here. So you can see now there's 4 hydrogen here, 4 hydrogen here, 2 oxygen here, and 2 oxygen here. Okay, this equation is balanced. This is one of the ways you can balance chemical equation in chemistry. Okay, now there are sometimes you may come across some complex equations that will be very complex to balance, that may be difficult to balance, and that's when you use the mathematical method that we want to use, which can solve can help you to balance complex equations. And these are the steps to follow when you want to balance equation using this mathematical method. And first of all, steps number one is to write the unbalanced equation, which is already written, but I would like to rewrite it because we may have to alter some things there. Okay, will give us carbon dioxide and water. Okay, so the second step is to assign variables to coefficients. We assign variables to coefficients of this equation. Whatever is here is what we refer to as coefficient. Let's say this A is here, B is here. Let's say what is here is C and what is here is D. Okay. Now, the next thing we do is we've done this. The next thing we do is to set up conservation equation. The way we set off conservation equation is to account for each of the atom on the reactant side, on the product side. Okay. Now, if you look at this, let's first account for carbon. Now, how many carbon are here? The number of carbon that is here is 2 times A. Okay. 2 times A. Okay. That's the number of carbon here. There's no other carbon here. Let's move to the other side. And the carbon here is, it must be equals to, okay, C times 1, which is the subscript here, but it's not just written there, right? Good. We have account for carbon now. Now, let's move to hydrogen. You know this is equivalent to 2A is equals to 1C, right? Now, let's move to hydrogen. For hydrogen, there are 6 times A, right? That's on this side, right? There's no hydrogen here. Let's move to the other side, which must be equals to 2 times D. So we can write this as 6A is equals to 2D. Okay. Now we've accounted for carbon and hydrogen. Let's now account for oxygen. Now on this side, there are 2 times B of oxygen, which must be equals to the oxygen on the other side, which is 2 times C. Okay. Then there's another oxygen here plus D, right? Because this oxygen have this coefficient. So this will be equivalent to 2B, right, is equals to 2C plus D. Okay. Now we have all these equations now. These are the things that we are going to work with now. Now, let's try to resolve this, right? Now, we see that 2A plus 2A is equals to 1C, which simply means 2A is equals to C. Let's first of all let's assume that A is equals to 1. Okay? If A is equals to 1, then C will be equals to 2 times 1. I'm talking of this now, right? Which is A. C is equals to 2 times, because we assume A is 1. 1, okay? Which is equals to 2, right? Meaning that if A is equals to 1, C is equals to 2, okay? Now, we have known the value of A and we have known the value of C, okay? But if we look at this place, we know that A is equals to 1. If we put A here too, let's bring this equation here now. This will be 6 times 1 is equals to 2D. Okay, so D will be equals to 6 divided by 3, which is equals to, sorry, 6 divided by 2, okay, which is equals to 3, right? Meaning that D is equals to 3. Now, we have known the value of A, which is equals to 1. We know the value of C, which is equals to 2. And we know the value of D, which is equals to 3. Okay? Now, can we substitute it in this equation now? Now, let's bring this equation here. If we substitute it in this equation, we will be able to get the value of B, which we don't know, right? So let's do it now. 2B will be equals to 2 times C, which is 2, right? Plus D, which is 3. So this will be equals to what? 7, right? So B will be equals to 7 divided by 2. Okay. Now we've gotten all our values. A is equals to 1, right? C is equals to 2, right? D is equals to 3, right? And B is equals to 7 over 2. So now you can have fractions in an equation like this, in chemical equation. What we rather do is to find a way to make this whole number. So what are we going to do about them? Let's multiply all of them by 2. This one times 2, this one times 2. this one times 2, and this one times 2. So with this now, we will see that A will be equals to 2, C will be equals to C will be equals to 4, right? D will be equals to 6, and B will be equals to 7. So now we have solved the equation now. The next thing is to substitute the values into the equation. Let's do it. Let me write it up here so that we can see. Now we see that A is equals to what? Is equals to 2. So that will be 2 C2H6 plus B is equals to what? 7. 7O2 is equals to giving us C is equals to 4, right? That will be 4CO2, okay, plus D is equals to what? 6, right? That will be 6H2O. We've substituted it. Now, let's verify if the equation is balanced. On this side, we have 4 atoms of carbon. On this side too, we have 4 atoms of carbon, right? Good. On this side, we have 12 atoms of hydrogen, which is 6 times 2. 12 on this side. On this side too, we have 12, right? Let's come to this side. For oxygen, we have 7 times 2 here, which is 14, right? Oxygen here. And let's see how many oxygen we have here. We have 4 times 2, which is 8, plus 6 here, which is equals to 14. So our equation is now balanced. Okay? If you are confused about this equation, you can go through the steps again. Okay? But once you get this method, you'll be able to balance any equation no matter how complex it is. Okay? Good. But let me tell you that there are these several methods that you can use to balance chemical equation, of which I just mentioned 2 of them. Just by trial and error, looking at the equation and some equation that you are familiar with, you just balance it like that. Okay. Or another thing you can do is to use mathematical method. When it comes to balancing redox reaction, that is another method which we'll be talking about by the time we get to reduction reaction. Okay. Now, having talked about the chemical equations, chemical reactions, and balancing chemical equation, let's look at some questions to practice what we have learned. Okay. Now, good. Let's balance this equation. Question number 1. They say they give us this equation and they say what is the value of A? Like I told you, there are some reactions that we are familiar with, like H2 hydrogen reacting with oxygen giving water. We know 2 will be here. Okay. So, and 2 will be here, 1 will be here, and 2 will be here. We know that. Okay. But if you want to use the mathematical method that we use the other time, let's quickly go through it. Let's account for hydrogen. 2A, which is on that side, will be equals to 2C, right? For oxygen, 2B will be equals to C, right? And that's it, I think. Now, let's balance this equation. Let's say A is 1. If A is equals to, or let's C is equals to 1. If C is equals to 1, 2A will be equals to 2 times 1, and A will be equals to 1, right? If A is 1 and C is 1, let's put 2B. If we replace C with 1 here, it will give us 2B is equals to 1 and B will be equals to 1 over 2. Okay, so A is equals to 1, B is equals to 1 over 2 and C is equals to 1. We can have it like this, right? Let's multiply all by 2 to make it whole number times 2 times 2 times 2. This one will be, so A will be 2, right? B will be 1, okay? And C will be 2. So we got it like that, right? So A is equals to 2. This is the correct answer using the mathematical method. Identify the type of reaction in the following equation, okay? Now, if we look at this, we have a compound that broke down to give us two products, okay? Potassium chloride and oxygen gas. What type of reaction is this? Combination? No, because combination is usually A plus B is equals to C to give C, right? The composition is usually A, B, breaking down into A plus B, right? Displacements, which can be single displacement or double displacements, you know what it is. You can go back in the lecture, okay? You'll see it. And redox is actually giving oxygen to a molecule, okay, or taking away electron and receiving electron from a molecule. So it can be this and it can be this. So the correct answer is this. If you look at this, it actually look like this, the composition, right? Now balance the equation. I think you should be able to do this one yourself. Try it and comment your answer in the comment section below, okay? Which of the following reaction is an example of a single displacement reaction? Let's look at it. Hydrogen combined with chlorine gas to give hydrochloric acid. This is what? This is synthesis method or combination. Synthesis reaction rather, or combination reaction, okay? This is single displacement, right? Because this one displaces copper from the copper to solvent, right? And this one is double displacement, okay? And this one is what? This one is also synthesis because two reactants combine to give one product, okay? So the correct answer here is this. Good. Let me leave the remaining question for you to answer. Go through them, write your answer in the comment section below, okay? And open up discussion. If you like this video, you can subscribe. If you enjoy the video, like, subscribe, and share with your friends for them to benefit, okay? So thank you for listening. I wish you the best. Don't forget to like, share, and subscribe to this channel. Bye bye. See you in the next video. Thank you.